What if Earth was near the center of the Milky Way? You ever look up at the night sky and wish Earth had a better view? Maybe you've imagined living closer to that glowing river of stars, the Milky Way's brilliant center. But be careful what you wish for. That sparkling galactic heart isn't a peaceful paradise. It's more like a cosmic war zone, and if Earth were there, we wouldn't just have a better view. We'd be fighting for survival. Welcome to a journey through one of the most hostile places in the universe. What if Earth was near the center of the Milky Way? Look up at the night sky, that faint, milky band stretching across the darkness. That's our home galaxy, the Milky Way. It's beautiful, mysterious, and unimaginably vast. About 100,000 light-years across, it contains upwards of 200 billion stars, plus planets, moons, asteroids, comets, and an untold number of other wonders. And out of all that cosmic real estate, Earth just happens to be parked in one of the most peaceful, stable corners. Right now, our planet orbits the Sun within the Orion Arm, a minor spur of the Milky Way's grand spiral structure. It's a bit like living in a quiet suburb, comfortably distant from the chaos of downtown. Specifically, we're about 27,000 light-years from the galactic center, far enough to avoid most of the noise, but close enough to still see that glowing galactic stripe on a clear night. It's an ideal location, not too bright, not too dangerous, just the right mix for life to evolve and thrive. But imagine if Earth packed up and moved closer to the galactic center. Not just a few light years, but right into the heart of the action, deep within the Milky Way's central bulge. What would it be like to live in the core of our galaxy? Let's just say, buckle up. At first glance, it might seem like a dream come true. The view alone would be jaw-dropping. The night sky would be ablaze, not with a few thousand scattered stars like we see now, but with millions, maybe even billions, depending on how close you got. The concept of night might disappear entirely. The sky would be lit with the fiery brilliance of tightly packed stars, glowing nebulae, and supercharged radiation. It'd be a permanent, dazzling cosmic sunrise. But with that beauty comes a terrifying truth. The galactic core is not a place built for life. It's dense, it's violent, it's unpredictable. In our current neighborhood, stars are spaced out. The nearest one to us, Proxima Centauri, is over 4 light-years away. In the galactic core, the distance between stars can be as little as a fraction of a light-year. That might sound exciting for interstellar travel, but for a planet like Earth, it's a disaster waiting to happen. All those stars mean more gravitational interactions. A passing star could yank Earth out of orbit, disrupt the solar system, or even send us hurtling through space. And that's just the gravitational threats. The radiation levels in the core are off the charts. The region is flooded with ultraviolet light, X-rays, gamma rays, and cosmic rays, all of which are hazardous to life. And then there's the violence. The core of the Milky Way is like a cosmic war zone. Massive stars are born and die at a furious pace. Many of these stars are short-lived giants that burn hot and fast before exploding in spectacular supernovae. These explosions don't just look dramatic. They release enough energy to sterilize planets, trigger mass extinctions, and shred entire solar systems. It's a region of extremes that Earth has never been exposed to. If Earth had been formed in the core, we probably wouldn't be here to talk about it. The early development of life requires stability, gentle conditions, protection from harsh radiation, and time. Lots and lots of time. The galactic center would have disrupted that delicate balance. Complex organic molecules, the building blocks of life, may never have formed at all. And if they did, the next supernova could have wiped them out before they had a chance to evolve. Even today, if we somehow picked up Earth and dropped it into the center of the Milky Way, the result wouldn't be pretty. Sure, we'd survive for a while. The planet wouldn't just melt overnight, but our biological systems, our atmosphere, our technology, all of it would be under assault from forces we're not equipped to handle. Living in the core would be like trying to build a house in the middle of a battlefield. The cosmic environment is constantly shifting. Stars explode regularly, and radiation storms sweep through like hurricanes. Not exactly a recipe for a relaxing evening under the stars. So why does the core exist in such chaos? It's because gravity pulls everything inward. Over billions of years, the mass of the galaxy has slowly migrated toward the center, concentrating gas, dust, and stars into a tight, volatile space. It's the beating heart of the Milky Way, where stars are born and destroyed at breakneck speed, the ultimate cosmic forge. For astronomers, it's a treasure trove of data. For life, it's a nightmare. Still, it's tempting to dream about the view, the idea of seeing the galactic core up close, of standing on Earth and looking up at a sky blazing with stars, is undeniably poetic. But the cost of that view would be the very conditions that allow life to exist. Our quiet little arm of the Milky Way may not be glamorous. We don't get front row seats to the galaxy's greatest fireworks. But in this case, being a little boring might just be the reason we're here at all. So, let's keep Earth right where it is, in a calm corner of a chaotic universe. The galactic center can keep its light show. We've got something even rarer, the gift of life. You can't see it, you can't touch it. But if Earth ever wandered too close to the heart of the Milky Way, radiation would become our deadliest enemy. Out here in our cozy little corner of the Orion Arm, radiation exists, sure, but it's manageable. Our planet is protected by a powerful magnetic field and a thick atmosphere. Together, they block or absorb most of the harmful cosmic rays and ultraviolet radiation that come our way. It's not perfect, but it's good enough for life to flourish. But the galactic center? That's a whole different story. Move Earth toward the Milky Way's core, and we'd be diving headfirst into a storm of high-energy radiation, unlike anything we currently experience. This is no ordinary sunburn scenario. This is cellular destruction on a planetary scale. At the core of the Milky Way, radiation floods the environment from all directions. Some of the sources include dying stars. Massive stars that collapse into neutron stars or black holes emit powerful bursts of energy as they die. Supernovae. These exploding stars release blasts of gamma rays and X-rays strong enough to sterilize entire solar systems. Neutron stars and pulsars. Their magnetic fields whip out radiation beams across the galaxy like cosmic lighthouses. Background galactic radiation. The very fabric of the galaxy's core is bathed in a diffuse glow of high-energy particles. Gamma-ray bursts, rare but devastating, these beams of energy travel at nearly the speed of light, and a single burst hitting Earth could end all life in seconds. The Earth's magnetosphere might try its best to hold the line, but it would be like trying to hold back a tsunami with an umbrella. The bombardment from every angle would simply overwhelm our planet's natural defenses. First, the ozone layer would begin to deteriorate under the stress of constant radiation. The ozone is our shield against UV light from the sun. Without it, UV rays would reach the surface unfiltered, causing skin cancers, eye damage, and DNA mutations in every living organism. Plants would wither, marine life would suffer, food chains would collapse. But this isn't just a problem for biology. It's a problem for the climate itself. Radiation at this scale would start to alter the chemical composition of Earth's atmosphere. Molecules would break apart. Reactive chemicals like nitrogen oxides would increase, disrupting weather patterns and slowly thinning the protective layers around our planet. Over millennia, solar wind, now stronger due to the weakened magnetic field, would begin to strip the atmosphere away, just as it did to Mars billions of years ago. Eventually, Earth could become a desolate, dry world, cold, barren, and hostile to life. Even our water sources wouldn't be safe. Cosmic rays are made of high-energy particles that can penetrate deep into materials, including oceans, rivers, and aquifers. This energy can split water molecules, produce harmful byproducts, and even make certain materials radioactive. Drinking water could turn toxic. Rainfall could spread radioactive particles across continents. And the worst part? There's no off switch. Unlike a natural disaster or a storm, radiation isn't something you can wait out. It's always there, always on, always lethal. Now, let's imagine that humanity tried to adapt. Maybe we built thick underground shelters, developed radiation-hardened crops, or created atmospheric shielding technologies. Even with our most advanced science fiction level tech, it would be nearly impossible to shield an entire planet from a radiation field this intense. You'd have to encase the world in a shell of lead, and even that might not be enough. Space agencies like NASA already understand the risks of cosmic radiation. Astronauts on the International Space Station are exposed to higher levels of radiation than people on Earth, and even they are only up there for a few months at a time. In the galactic core, the ISS would be obliterated in hours. Radiation shielding used for Mars missions wouldn't even scratch the surface of what we'd need near the Milky Way's heart. And here's a chilling thought. Even if we didn't move the whole Earth, just sending a spacecraft or a probe into the core could be disastrous. Delicate electronics would fry. Sensors would go blind. Even robotic explorers would be reduced to expensive space junk. So let's be clear, life, as we know it, cannot survive there. Not on the surface, not in the oceans, not even in underground bunkers. Not for long. Radiation is the silent killer of the galaxy. It doesn't roar, it doesn't flash, but it quietly shreds DNA, mutates cells, and tears apart atmospheres. It's the reason the galactic core is likely devoid of advanced civilizations. It's not that they aren't out there, it's that the conditions are simply too hostile for complex life to survive long enough to build anything meaningful. We often dream of visiting the bright center of our galaxy. And sure, the view would be breathtaking, a panorama of stars so bright you could read a book at midnight. But beneath that celestial beauty lurks a deadly reality. Radiation doesn't care how poetic the night sky looks, it just kills. So maybe, just maybe, our quiet little perch on the edge of the Milky Way isn't such a bad place after all. In our universe, stars are born, live their lives, and die, just like living things. But in the heart of the Milky Way, that life cycle is put on fast forward. Stars there are bigger, hotter, and far more unstable. They burn their fuel fast and go out in style, with a bang that echoes across the galaxy. That bang is a supernova, one of the most powerful explosions known to science. When a giant star runs out of fuel, its core collapses in on itself, and in an instant, the outer layers are blasted into space at tens of thousands of kilometers per second. For a brief moment, that single star can shine brighter than an entire galaxy. Here in our peaceful corner of the Orion Arm, supernovae are rare and far away. But in the galactic core, Earth wouldn't just be near the occasional dying star. It would be surrounded by dozens of ticking time bombs. Imagine living in a neighborhood where every few thousand years, a house randomly detonates with the energy of 100 trillion nuclear bombs. That's what it would be like near the center of the Milky Way. Supernovae are beautiful, sure. They light up the galaxy with glowing nebulae and enrich space with heavy elements, the same elements that make up planets, people, and life itself. Without supernovae, you wouldn't have iron in your blood or gold in your wedding ring. But when one happens too close, it's a planetary death sentence. If a supernova occurred within 50 light-years of Earth, the planet could be completely sterilized. The intense gamma radiation would strip away the ozone layer in minutes, exposing the surface to deadly levels of ultraviolet light. Crops would die. DNA would break apart. Ecosystems would collapse. Life would face an extinction-level event, no asteroid required. And the galactic core doesn't just have one or two of these monsters. It's packed with short-lived, high-mass stars that are constantly being born and dying in supernovae. The time between these catastrophic blasts wouldn't be measured in hundreds of millions of years, like on Earth today. It could be thousands of years, hundreds, or even less. That means Earth wouldn't have time to recover. A mass extinction event would just be the beginning. Before life could re-evolve or ecosystems bounce back, another supernova could hit. Then another. Then another. It's like trying to grow a garden in a war zone. But the danger isn't just from radiation. Supernovae also shake up the structure of space itself. When a star explodes, it doesn't just blast energy outward, it also sends shock waves rippling through the interstellar medium. These waves can disturb gas clouds, trigger new stars to form, and, critically for us, destabilize the orbits of nearby objects. What if Earth wasn't hit directly, but instead its orbit around the Sun was disrupted? If the solar system's balance were nudged by a close enough explosion, Earth could be knocked off its orbit, or the Sun could drift from its place in the galaxy. One wrong gravitational push, and we're suddenly ejected into deep space, a frozen dark world drifting endlessly through the void without a star to warm it. Or worse, Earth could veer off course and collide with another star system. The gravitational chaos could tear the planet apart or send it spiraling into a new star, frying it into oblivion. Even smaller disruptions, changes in asteroid paths or comet trajectories, could be devastating. A supernova shockwave might redirect a distant asteroid toward Earth, setting off an impact event not unlike the one that likely killed the dinosaurs. Only this time, it might happen over and over again. We don't often think about how fragile Earth's position really is. We orbit the Sun at just the right distance, at just the right angle, protected by a solar system that's largely empty of dangerous debris. It's a delicate dance, and in the core of the galaxy, the music is constantly being interrupted by explosions. And let's not forget, even if humans somehow built radiation-shielded bunkers, underground cities, or orbital habitats, no structure could withstand a direct hit from a nearby supernova. The shockwave alone could vaporize our technology, knock satellites out of orbit, or boil away the atmosphere.